So in this video, we're going to look at how to solve a system of linear equations by the elimination method. So elimination method, usually when you look at the two equations, you will see that looking at the numbers in front of x or y, we found that these are opposite of each other, or these are equal. So solving by elimination method will be quicker, because when we have two equations, we actually can add both the equations or subtract both the equations. For example, if we have, let's say, 3 equals 3, 5 equals 5, these are two equations. We can add to the left-hand sides of these two equations to get 8. And on the right-hand side, we can add them, we can get 8, and they're still equal to each other. And we can also subtract them. So if we have 3 equals 3, 5 equals 5, then we can do subtraction. 3 minus 5, subtract the left-hand sides and subtract the right-hand sides, and we know they're still equal to each other. So because equations have this property, we can use this idea. For example, we know 5y and negative 5y, they are opposite of each other. If I can add the two equations, add the left-hand sides and the right-hand sides. And when we add the left-hand sides of the equation, we add combine like terms. So for example, 3x plus 6x, that gives us a 9x. And 5y minus 5y plus negative 5y, which is 5y minus 5y, they cancel each other. And on the right-hand side, we notice that negative 1 plus 28, that's 27. And immediately, we got rid of the variable y. And we can solve for x. In this equation with only one variable, we can divide both sides by 9 to get 3 as the answer for x. So the idea of elimination method, or previously the substitution method, we have a common goal, which is to get rid of one of the variables. So notice that previously when we plug y into the second equation, we got a new equation, sort of complicated, but y disappears, because we know how to solve for equation, solve for x with only one variable in the equation. And with the elimination method, we didn't have to plug in. All we had to do was to add these two equations. And because 5y, negative 5y, after we add them, they disappear, which means y disappears. And so we can solve for x in this one variable equation. And with the elimination method, the substitution method, after we got our variable for x, all we had to do is to plug this into one of the equations and to solve for y, the other variable. So right here, we can do the same thing. I can plug 3 into one of those equations. So usually I'll try to pick the one with the smaller numbers. So I'm going to pick the first one and replace this x with 3. We don't get y immediately like before, but we can solve for y because it still has only one variable. Okay, we subtract 9 from both sides. We are going to get 5y. 5y equals negative 10, because negative 1 minus 9 is negative 10. And we can divide both sides by 5, which gives us a negative 2. So the solution for the first one, first system, we have x equals 3 and y equals negative 2. Okay. Now, notice in the second system, we have these two. So we look at the numbers in front of x and y to see if we can get opposite of each other, or in this case, equal to each other. If they're equal to each other, notice we can also do subtraction of two equations. So this time, I'm going to subtract these two equations. But when we do subtraction, we got to be careful. So the minus is between all of these. So there's a minus here, sort of similar to long division we did before. So we have 8x minus 8x. They cancel. But it's going to be negative 3y minus 7y. That gives us negative 10y. So again, it's negative 3y minus, because we're doing subtraction between these two equations. So I'm going to put, there's a minus sign between 8x and 8x. There's a minus sign between negative 3y and 7y. So that gives us negative 10y. On the right-hand side, we have 10 minus 20. That's also negative 10. So we divide both sides by negative 10. We get y equals 1. And now we just need to plug y equal to 1 into one of those equations. So again, I'm going to pick the first one. And you can actually plug into either of them. If you want to plug into the second one, that also works. So let's replace this y in the first equation. Replace that y with 1. We got 8x minus 3 equals 10. And we add 3 to both sides. Let's get 13 and divide both sides by 8. So we got a fraction. Now, two solutions will be x equals 13 over 8 and y equals 1. And this does not always happen. The numbers in front of x or y, they are either opposite of each other or equal to each other. And if they're not, so for example, I could come up with a problem quickly. Let's say we have 8x minus 3y equals 5. And the other one, we may have 7x plus 2y equals 3. And in this case, when we look at the numbers in front of x's, they're not opposite of each other, they're not equal to each other. And the same for y, not opposite of each other, they're not equal to each other. So in this case, we have, how do we use elimination method? We can change them to the same number. Although in the homework, I didn't give you any question like that. But what we can do is, we can find what we called sort of like the least common multiple. So for example, 3 and 2, what they have, I can change both of them to 6. Because when we have an equation, we can multiply both sides by the same number. So in the first equation, I multiply by 2, and the second equation, I multiply both sides by 3. That will change when I multiply 2 here, and 2 there. That's going to change the numbers in front of x and y to 2 times 8 is 16, 2 times 3 is 6, and 2 times 5 is 10. If I multiply the second equation by 3, so every number is multiplied by 3. Sorry, I missed the y here. And now, notice that after I do that, they're going to be opposite of each other. I can add 2 equations to get rid of y. So that's a way to, if they don't have any matching numbers or opposite, we can find the LCD, the LCM, the least common multiple, and it's 3 and 2. They have least common multiple 6. So we can multiply the first one, change both of them to 6. Let's see, this one is changed to 6, and this 2 is changed to 6. Now they are opposite of each other, so we can add them. If they are equal, then we subtract them. Okay.